Hello chemists, today we are going to explain Joule-Thomson effect. So in Joule-Thomson effect, we have a stream of gas. Suppose we have like I am going to explain you an analogy here. Suppose we have a cylinder, like whatever a gas cylinder which we use in our homes. So the gas cylinder contains gas at high pressure, and as compared to the inside pressure, the outside atmospheric pressure is low as compared to the inside pressure of the cylinder. So suppose the pore the porous plug suppose the porous plug of the cylinder is leakage or somewhat, like, so that the gas releases from it. So now there are gaseous molecules inside the cylinder at high pressure. So when they are allowed to expand by passing through this porous plug into the outside atmosphere, or suppose from a region of high pressure to a region of low pressure, or vacuum, whatever, under adiabatic conditions, that is, no flow of heat takes place, then the gas gets cooled, or the cylinder has ice on its outer surface, that is, the inner gas gets cooled. Why is it so? It is due to Joule-Thomson effect, and its general introduction, and now we are going to explain this. So the phenomena of change of temperature produced when a gas is made to expand adiabatically from a region of high pressure to a region of low pressure or vacuum is known as Joule-Thomson effect, which I have explained you here. So as you know that that the, that the gas particles are inside, like they are exerting pressure on the walls of the cylinder. So why the cooling is there? The cooling is due to the decrease in the kinetic energy of the gaseous molecules, because a part of this energy is used in the expansion of the gas from high pressure to low pressure, and also a part of the energy is used during expansion is used in the overcoming the van der Waals force of attraction inside this of this gaseous molecules. Van der Waals attraction between the molecules, because when gas expands, it has to overcome the attraction between the molecules, so that the molecules go from a region of high pressure to a region of low pressure, so that it is very small when gas approaches ideal behavior. Because in ideal gas, we assume that pressure is zero, so work is zero. Pressure is zero because the van der Waals force are almost negligible in that case. Hence, so Joule-Thomson effect is zero in an ideal gas. So when an ideal gas expands in vacuum, there is neither absorption nor evolution of it, that is, Q is equal to zero. That is why as I say, the van der Waals force are negligible in an ideal gas, and there is no expenditure of energy in overcoming these forces during expansion. Hence, this is Joule-Thomson effect. So I am writing the definition of this effect here. So the phenomena of just a minute. So the phenomena of change of temperature during expansion of a gas from a region of high pressure to a region of low pressure or vacuum is known as Joule-Thomson effect. So as you see, the phenomena of change of temperature during expansion of a gas from a region of high pressure to a region of low pressure or vacuum is known as Joule-Thomson effect. So also, when an ideal gas expands in vacuum, it does no work, as I said earlier, because the pressure against the walls which it expands is zero, hence work is zero. So the using first law of thermodynamics, delta U is zero as there is no work and it is done under adiabatic condition. So Q is also equal to 0. So this is delta U is equal to 0. Hence no change in internal energy takes place. In other words, what I want to say, that is the internal energy of a given quantity of an ideal gas at constant temperature is independent of its volume, that is del nu by del T at del V at constant temperature is equal to 0. So an ideal gas can be defined thermodynamically by the following two equations. The first one is PV is equal to constant, as there is no work, what I have said earlier. And the second thing is del U by del V at constant temperature is equal to 0. So and these are the two necessary conditions which are required for an ideal gas to show Joule-Thomson effect. Hence I hope you like this video, so please like, share and subscribe the channel, and I am going to explain this in the next video. Its remaining part is also there. Hence, thank you.